Okay, good afternoon everyone, Pranhandar. Lovely to be here. Nasi Bod Yma heddiw. I am from Wales originally, now exiled in London, so it's good to be back in my homeland to talk to you about Project Ava. For those who are wondering, Ava got its name from the AI robot in the Hollywood movie Ex Machina. A very good film, but I often get asked where the name came from, and that's the image there. So, who am I? Pwy ydw i? I am the UK Research Director at NCC Group. I've been in cybersecurity about 17 years, straight out of university, so it's pretty much all I know in terms of my career. I had about 10 years as a Czech team leader, CREST certified, mostly in web application testing and network intrusion analysis. I was in the KPMG pen test team. I worked at IRM as a pen tester, and I started my career at CSG, which was part of GCHQ, straight out of uni. And so, yes, I'm a Swansea boy. I did my first degree at Swansea in computer science, and then went to Oxford for a year to do my master's in the same subject. And the reason why I'm here today, I think, mainly as well also, in terms of my research interests, I'm a big fan of tooling and methodology and automation. So anywhere where within security we can get some sort of efficiency gains within security testing, that's a great interest to me. And so this project was a nice way to sort of explore some new techniques in that realm. So what I'll go through today is I'll go through an overview of what Project Ava was, about 10 parts or phases to the actual project. And fundamentally, I want to share our lessons learned. The research that we did on this was very exploratory, very new to us. We hold our hands up that we're not experts in this domain, and so that's why we want to share with people to sort of get some discussion about what the role of machine learning might be within web application and more broadly penetration testing. We'll talk about some different approaches that we tried, supervised, unsupervised, and reinforcement learning, and we looked at expert systems as a type of approach also. I'll go off on a brief tangent, which is one of the things that happened during the research as we were playing with natural language processing. We sort of saw some potential applications of machine learning within a social engineering context, which was quite interesting. Nothing to do with what we were trying to do in the first place, but it was an interesting tangent, and I'll go into that. And then I'll summarize what the outcomes were from our research and what we feel are the next steps, not just for us, but as an industry. So Project Ava came about, I guess, mainly because, as you're probably all aware, machine learning, AI, it's not just a buzzword now. It has crept into the cybersecurity space. There are lots of products, systems, services that use those techniques. We wanted to understand whether we can use any of those techniques within our web application testing process. NCC Group is probably one of the world's largest security testing teams. We do hundreds of web app tests every week all around the world. If there's any way that we can gain efficiency gains by using machine learning or AI, then that's of course of interest to us. I'm not saying that just because we can then try and get more work in. What we want to do is maybe use some level of automation to do the low-hanging fruit, the easier stuff, to allow us to focus on the more manual side of things, the complicated things within web app testing that maybe aren't that achievable with current AI or machine learning techniques. We set out to do something around augmentation with our human-based testing rather than replacement. So we didn't want to sort of try and create an AI robot that just does web app testing. We knew we'd be doomed from the start if we tried to be that ambitious. So we were looking for ways to complement how we already do web app testing. I mentioned the efficiency gains. We also wanted to use the project as a vehicle to learn about machine learning. Like I said, it's for NCC, it's not typically our strength. We know security and penetration testing very well. We're not really data scientists, so we wanted to use the project as a vehicle to help us upskill with the different concepts in that area. And also to understand, is the ML AI thing just hype, or does it actually have some positive applications? So it was quite an ambitious project for us, probably a first in terms of its scale. We got approval for about 400 people days worth of effort because we knew there'd be a lot to do here. And it was purely experimental with no preconceived ideas of output. So we didn't set out to create something that we would take to market and start making money off it. That just wasn't the the rationale at all. We were fully expecting that maybe nothing would come of this at all, but we would explore what was possible during the process. Most importantly, even though I'm here talking today, all of the research and the hard work was done by my colleagues on Team Project Ava, who are listed here. So all the work and credit is to them. I just did some little direction here and there and was a bit annoying now and again in trying to get some deliverables from them in terms of a management type thing. But yeah, this is all their work that I'm presenting today. So part one, very briefly for us, was to just look at what are the frameworks out there. Like I said, we were starting from ground zero. We understood that there were a few different frameworks that people are using to do AI and machine learning. Most of them are open source. So we downloaded them all. We created some virtual machines, some playgrounds to sort of play around with them, with some free and open data sets, not on web app testing, but all sorts of different things, just to get a feel and understanding of which ones might be best fit for purpose. The TLDR was, I guess, these three kept cropping up a lot and seemed best fit for our purpose. So scikit-learn, Python-based, a bit more in the academic space, but very good for quick prototyping. TensorFlow and Keras as a sort of higher level wrapper around TensorFlow coming out of Google, seems to be one of the more prominent frameworks used in this space. So there's a lot of support for it, there's a lot of guidance out there, and also the Python aspect was attractive to us because we know Python quite well and have a lot of Python coders within the organization. So only for those reasons did we sort of home in on these to do the rest of our research. There's no slur on the other packages. I'm sure they are equally good at doing their things. Certainly Cafe 2, which have come out of Facebook, a lot more geared towards image recognition, that sort of thing, and that's not really what we were after for our research purposes. We also looked at the different cloud-based solutions that are out there as part of this. I don't know if any of you had a chance to play, but most, if not all, of the public cloud providers have a number of just quite simple wizards that let you, without much, if any, knowledge of machine learning and AI, play around and experiment with lots of things in this space. So certainly Microsoft, AWS, Google, IBM Watson, formerly Bluemix, which I'll come on to in our social engineering piece. And we looked briefly at the Alibaba machine learning platform for AI also. And if you haven't seen it, just to sort of show, this is one of the screenshots from the Amazon machine learning, I guess, framework within the cloud. And it's just a very simple next wizard type thing. So if you've got some data, this will walk you through the process of uploading it, selecting your features, training some sort of model to do something, and then, hey presto, you've got your machine learning model in the cloud that you can then start pumping real-world data in. So it was quite interesting to sort of understand that these exist and how easy they are to use, how much they abstract away from the data science aspect of the hardcore maths and algorithms in the background. So making machine learning very accessible to most people. Similarly, this is the one from IBM, one of their data science playgrounds. A little bit more detailed. Maybe you probably need to know a little bit more about what you're doing here. But here you can drag and drop your process. This is for an image classification system, and then very similar. Next. Bang. There's your machine learned model. So while we were looking at those cloud solutions, and particularly IBM Watson, which has got a lot of powerful AI and machine learning capability, do all sorts of things. One of the quirks of research is usually you do go off on a tangent sometimes, completely unexpected, just something that looks interesting and curious. And so that's what happened when we were playing around with their NLP, their natural language processing capability. And where it came about was they have a playground. You can sign up for free for, I think, 30 days for IBM Watson Access, and you can play around with a number of different features that they have within NLP. And they have one thing that says, type in your Twitter handle here, and we use natural language processing on a massive trained model to work out what your personality is based on how you write and what you've written. So I uploaded that based on about 3,800 words from my tweet history, and it comes back quite quickly with this summary. So I was initially a little bit miffed because it's like, well, you're a bit inconsiderate, shrewd and heartfelt. Never thought of myself as inconsiderate before, but I think a lot of that might be because On Twitter, I tend to adopt a slightly different persona to myself, and maybe a bit more sarcastic and angry on Twitter, aren't we all? And I think that was picked up. But also, this particular demo is more geared towards people who work in market research, who do profiling to do targeted ads. But it picked up that I have experience playing music. That's true. I play a few instruments. It picked up that apparently I don't like country music. That is true. I'm not particularly a great fan of that. So this piqued our interest in that. This looks quite interesting in that it can, with a fairly limited amount of data, pick out some things that seem quite accurate about me as an individual. So we probed this in a bit more detail, and in the background to this is a full-on API into Watson's NLP that you can interact with and query. And basically, if you have a lot of data, you upload that, and it comes back with a lot more information about people's personalities. Specifically, it's aligned to what's called within psychology the Big Five. So I'm not a psychologist, but I read more into it as part of this, and apparently, our personalities, our individual psyches can be broken down into these 5 main aspects of agreeableness, conscientiousness, extroversion, emotional range, and openness. And then within each of those, you have different facets that are broken down even more. So with agreeableness, you've got things like altruism and cooperation. You know, how cooperative might you be as an individual? How modest might you be? Your morality, your sympathy, trust, that sort of thing. But this got us thinking around. We do a lot of phishing exercises, social engineering as part of red team engagements. And while we sort of try and home in on, I guess, specific individuals of interest, this sort of takes it a bit further than that. If you have this information on your targets, our hypothesis is, well, if someone comes across as particularly trustworthy, maybe they're more likely to click on a link or download something. So you're exploiting some aspect of their personality. So we wrote this sort of quick little tool to sort of try and demonstrate that, called PIMS, which stands for Personality Insight Manipulation Suggester. It goes up, you give it a bunch of text, whether it's someone's tweet history, their Facebook data, or a thesis they've written. The more data, the better. And the more applicable it is to your target, the better. And it comes back with a breakdown of these different facets. And anything that's about 0.75 or above is deemed to be a strong indicator of that facet. So likely that person does have that. So for me, apparently I'm fairly highly sympathetic and trustworthy, which makes me a bit nervous. And I maybe have to sort of tone that back a bit. We haven't done any in-depth tests with this, but it seems like an interesting curiosity that might have some weight if we're trying to maximize the likelihood of somebody, a target, clicking on a link by virtue of exploiting some aspect of their personality. Put my hand up. It feels a bit scummy. I mean, it feels a bit sort of invasive doing that. But it's also interesting that if we do some tests in this space and get some strong correlations, it might be a good way to then understand how maybe different individuals need to be trained in different ways about the risks of cybersecurity and the risks associated with phishing. So we're looking at that further as a curiosity, and we may try and loop that into our phishing platform called Piranha as a future extension. Just for fun, we also at the same time, since we'd collected all my tweet data, played around with Markov chains. Markov chains allow you to do a number of different things like simulating text based on a corpus of text. So I used this script here, slightly modified from GitHub, trained it, well, it's not training as such, but used it against all my tweet history, and then I tweeted out with a hashtag Markov match so people knew it wasn't me, some of the outputs that came from the tool. So this one here, I hear GDPR is a diuretic. 1 kilo of that stuff will have some interesting effects. That was quite funny. And then the one over the other end started talking about the Welsh Assembly and ninjas and all sorts of strangeness. But it sort of makes sense, sort of doesn't. It's a mishmash of a lot of the stuff that I've previously tweeted about. But it was an interesting and a funny quirk of what we've been looking at. So like I said, that was a massive diversion. We had to stop ourselves getting too deep into that. But we have sort of spun that off into a separate research stream. So getting back on track with Project Ava, Before we launched into sort of doing any coding or playing around with stuff, we wanted to understand what's been done before. Always within research, a good positive step. You want to see who's done what before. You don't want to duplicate effort, that sort of thing. So we looked across academia and industry, how successful had previous attempts been, and with that we wanted to understand, were we being too ambitious with just 400 days worth of effort assigned to this project? Who are the main players? How long has it taken them? And then can we reuse anything that might be open source in this domain? In short, not too much came out. These three came out as sort of things of interest. So Isao Takaesu is a researcher in Japan. He's published a lot, been quite open about what he's been doing around using AI and machine learning, not just in web app testing, but penetration testing more broadly. Since we did this research, he's published a lot about using AI combined with Metasploit to do a lot of intelligent scanning and exploitation. So really interesting stuff. He seems to be one of the main leaders in this space. CloudSec had a very interesting approach using intelligent crawling. So they trained some good models to intelligently crawl a website and work out when something is a login page or a search page, and then from that go and launch the various attacks that you would typically run against those types of page or function. So search being usually you would look at cross-site scripting in any reflected search terms or SQL injection, that sort of thing. And then there was a commercial offering by High Tech Bridge, who had this ImmuniWeb AI, which we haven't played with, but they have that collateral on their website that they have that claimed capability. So most of what we saw were fairly good crawlers, so people using AI or machine learning to do intelligent crawling of a website, with some little bits of AI or machine learning for the actual attack stuff, but not that much. Academia was really great for specifics. There were some very good papers out there on trying to do cross-site scripting, just one type of attack using machine learning or AI, that sort of thing. But there wasn't too much in the way of complete systems. Patents. There are loads of patents out there at the moment. Everybody's sort of trying to get ahead of the curve with the ideas that they have about machine learning in penetration testing. Having a read of them, though, there's a lot of, there's not much information in the patents. So they are quite dubious, but you can see that people are trying to get a bit of a land grab on what might be a good idea at some point soon. So there have been some gains. I mentioned the crawlers, some solutions focusing specifically on certain vulnerability classes like SQL injection and cross-site scripting. We didn't see one particular strong solution in this space. Sadly, I guess there was nothing massively usable from the open source. We did find a lot of projects, but as sometimes happens, they get abandoned or nothing's really happened in a few years. We found quite a few going back 10 years. So even though machine learning AI has been around, is a hot topic rather in sort of the recent two or 3 years gone, people were looking at this 10 years ago, which was interesting, but most projects were abandoned. We noticed that most people who had succeeded had only released some of their work, probably because of intellectual property, which makes sense. And so, even though we haven't sort of highlighted anything that we think, oh yeah, here's a massive player in this space and it's going to be a big game changer, that doesn't mean that isn't going to happen at some point soon. Somebody might be sitting on that type of intellectual property and it could land any moment, but we didn't see anything obvious in that space. So we knew that we'd have to sort of start pretty much from ground zero. Excuse me. Before we did that, we sort of set out to properly architect and design what we wanted to achieve. I guess naively we thought, well, one of the world's largest security testing teams, we capture loads of data. You need lots of data to do machine learning and AI, so job done. This is going to be easy. But actually, within a large commercial organization, there are some barriers that doesn't make that as easy as one might think. So, firstly, we have contractual obligations. Even though we have lots of clients, we have different terms or contracts with them. Sometimes our contract will say, you will allow us to use your data as part of ongoing research, and that doesn't get queried and that remains in the contract. Some clients don't like that, and that, as part of the contractual negotiation, that gets written out. So in addition to some retention. So, some clients require us to delete their data at the end of testing. So it's not that we do have this instantly accessible massive database of data as we sort of naively thought we would have. Also, about the time that we were doing this, about May last year, it was literally when GDPR was about to come into force. That was a hot topic, obviously, at that time, and that focused our mindsets a lot in terms of, well, if we're thinking about creating a database with all sorts of web app traffic from all our clients, you think about what might be in a web request response pair, things like usernames, passwords, they could be in clear text, they could be session identifiers that are still valid. Contextually, whatever the application is, there could be some sensitive data like financial data. We instantly started to sort of wince a bit around, if you have all of that in aggregate in one place, that's quite a minefield in terms of the risk that you're running having that sort of thing. So I think GDPR was a good thing in that sense, in that helped focus our mindsets there, with it being a hot topic at the time, rather than the temptation of just saying, yeah, let's just get all the data and start training some models. And also, in terms of storage location, so, we had to decide, are we going to do all of this on-premise? Are we going to embrace the cloud? Are there issues in uploading our client data to the public cloud? So all of these things we did have to consider. This is what we came up with in the end. So for any data that we were contractually allowed to use, or data we were allowed to accumulate either from open data sources, or we used a lot of, where we have known vulnerable training web apps, we were able to generate the data we needed by using those. And if we did have any sort of legacy data, we could consume that in if it wasn't violating any contractual agreements. So we produced a number of plugins to our Burp Suite arsenal. So we're big users of Burp Suite for our web app testing because it's very well extensible. So this was assuming that, okay, well, let's have all our consultants running the extension. It will allow them to do some supervised learning, tagging of the data that we need. We can consume anything legacy that we've got. We then pump that into an Elasticsearch instance. We decided to go internally in the end, so we didn't use any cloud just to minimize risk that much more. And then what we called this was the anonymization or pseudonymization boundary, where we could, we would anonymize the data to even more reduce the risk of any exposure in that regard. Then that Elasticsearch instance would give us that pool of data that we could then generate our training data. So this is essentially a way to amass lots of web request response data and to use the power of our large security testing team to manually tag in a supervised learning way. We did also generate a lot of synthetic data in the early part of our research as well, just in the interest of being able to get up and running quickly, but with a massive caveat that obviously synthetic data isn't ideal. You do ideally, for good results, need representative and realistic data. So it was very simple in that what we were doing as part of our training within the research from the plugin within Burp, every time a consultant would have a confirmed vulnerability from their manual testing, they could just right-click, send a project over, and categorize what the vulnerability was, whether it was a SQL injection, cross-site scripting. Eventually, we got a few other bug classes into that list. So that's the approach that we took. So the first prototype that we had, given that we now had some corpus of data, was we first looked at text processing and semantic relationships, on the sort of the assumption that, well, okay, you have a web request and response pair. There might be some relationship between what was sent to a server and what came back by virtue of what you typed in and what the vulnerability might be from what you've observed. So, for example, when you're doing cross-site scripting, you type some stuff in a field or a form, goes to the web app, something happens, and you get maybe a 500 error back, and there might be a verbose SQL error. So you may be able to learn or identify some correlation between what the request was, what the response was, and that infers a specific type of vulnerability. And this just sort of shows an example where we chucked in a load of data to this word-to-vec feature, which is a very simple neural network, which does semantic relationship learning between words and pairs. So this is where it shows that it learns that, if you give it a word set cookie, it's learned with high accuracy that other words that are semantically related to set cookie are the secure flag, the HTTP only flag, the path, 301 for whatever reason in this example. And so it was building on this sort of premise that rather than having to code regular expressions to try and pull out what we're interested in, this is basically having a machine try and learn and infer those relationships itself. Just to further exemplify, so this was from our synthetic data where we generated lots of data, and then when you search for words that related to insecure, you get all sorts of stuff that comes back related to crypto, OpenSSL, words like error and obsolete. And similarly for SQL, you get words like injection, statements, query, that sort of thing. Excuse me. Like I said, this is new stuff to us, so there are a number of different models that you can use, different algorithms you can use within machine learning and AI. We tried pretty much as many as we could, very much in the sort of let's munge this type fashion, let's just throw lots of data, try different algorithms. This is from our Jupyter notebooks where you're trying all sorts of different Bayesian classifiers, support vector machines, different convolutional neural networks, that sort of thing, just to see how different algorithms were performing in different ways. On the synthetic data that we'd used, if anyone is a data scientist, I'm not, but there's some sort of specifics about the parameters that we had. We had some results back. It wasn't very good at identifying insecure cookies. We suspect that's because of the high entropy that comes associated with a cookie value that is random. So it was getting quite confused on that. But we could infer with good accuracy missing cross-site request forgery, missing cause. SQL injection and cross-site scripting was in the 70s, 80s. But again, massive caveats, small data set, synthetic data. We need to do a lot more testing. So we didn't sort of raise our glasses and say, yay, we've cracked this at this point. This was still very early days. So the next thing we looked at was the second prototype. Rather than try and do something like a catch-all, so in the first one we were trying to identify cross-site scripting, SQL injection, a number of different classes of vulnerability all at the same time. Let's just try and focus on one type of vulnerability, so SQL injection. But also let's focus on one type of vulnerability against one type of actual database, so MySQL as the database management system. Thinking that maybe we can get better results by just focusing on a smaller target set. And so for this, we also removed the use of synthetic data. So we used, well, I say real vulnerable data. It was data that we captured from doing all sorts of crawling and scanning of known vulnerable web apps or training apps, like the damn vulnerable web app, Mutilidae, that sort of thing, vulnerable WordPress, all of which had MySQL as a back end. So that gave us our data set. And this was the process that we did. So very much like the first prototype, we trained the model. We found that support vector machine multiclass was giving the best results there. We test a new MySQL application using that system. Then we'd select all the false positives. So we had an additional plugin into Burp to allow us to select what the false positives were and tag them as non-SQL injection. Then that would retrain the model for us. We'd go back and sort of retest the same application to see if the number of false positives have reduced. And then that was sort of the process to try and refine a lot more. And then we would continue testing with new MySQL-based applications. And with that, we did get about 99% accuracy after a few iterations of retraining. The way that the plugin worked for us is that as we were testing, the model would be running in the background, and then using the Burp intruder, so this is the output from an intruder, it would highlight in red those ones that it thought from what it had learned, those responses which were much more likely to be SQL injection, like confirmed vulnerability. So it felt like there was some good merit there. But again, we didn't throw our glasses up and say, yay, 99%. There is a temptation to do that. We're aware that that does happen in the industry. You can train a model, do some testing, the numbers look good, and then you sort of release your product. But we still need to do a lot more testing in that space with bigger data sets. But it showed some promise, and it was an improvement on the first prototype. We then sort of stopped and looked back at what the various issues were that we'd experienced with the first two attempts. There were some issues around, well, in the previous ones, we're sort of trying to read HTML like we do, like we read a book, but that's not typically how we do testing. There are other aspects involved with trying to infer if a vulnerability exists. And also there's an issue with different locales, right? So you could train a model on English language-based web apps, but what if you come across a web app that's got error messages in Chinese or Japanese or whatever? That's going to completely not work. So, that's an issue. As we said, the web request response pairs, the data itself might be sensitive in some way, so that's an issue. And then the supervised learning aspect, it does require human effort to do the tagging and labeling. Pen testers, I count myself in this, we're quite lazy. You ask a pen tester to do something else that's quite boring. They probably don't want to do that, or they might forget to do it. So we realized that, we can't rely on that as a way to constantly be getting our data. So then we looked at, well, okay, can we flip the idea on its head and look at anomaly detection instead? So rather than trying to learn and detect known bad, why don't we sort of learn what we think is known good? I hesitate to say known secure because you never can confirm that completely, but what you think is sort of roughly good in terms of security. And then you do anomaly detection such that in the future, something that pops up as an outlier from what you've trained, that might be the vulnerable thing. And also in doing this as well, rather than using the data type that we'd used so far, we thought, let's see if we can do some proper feature engineering and pull out lots of metadata around what we capture rather than the data itself and train our models based on that. So, for example, for feature selection, when you've got a lot of web data, requests and responses, you don't necessarily have to inspect the traffic itself if you're trying to possibly infer or identify vulnerability. You've got lots of numerical data that you already have or can generate. So you've got HTTP response codes, quite simply, and HTTP 500 as an error could be a strong indicator just on its own. You've got the differences between response codes in terms of what was the previous request to the current one. You've got the response size and the differences in response sizes. So again, depending on what your attack string was or what you sent to a server, if a lot of data comes back, that could be indicative of some sort of SQL injection that returned a lot of data. You have like response delay or time lag, so there could be some time-based type issue that you can infer if you capture that sort of data. And also all sorts of just interesting stats about the response body rather than the data itself. So you might capture the number of vowels or consonants or symbols. And the more data that you have in that space, the more that you can capture and train, might then ultimately lead to a model that gives you some interesting insight as and when you come across something vulnerable, which stands out as an outlier. So this one, again, I know there's a theme here. We didn't have any strong conclusions here. It feels like there's some merit here, but we need to do a lot more experimentation and training here with a lot more data sets. But this at least gives a few approaches that takes us away from the data protection privacy issue that we have from previous attempts. For the fourth approach, we sort of looked at reinforcement learning and genetic algorithms. So this is sort of the more interesting but much more complex AI type stuff where you're making a system properly learn how to do stuff, and sort of through genetic algorithms, it mutates itself through that sort of prize reward type system. Again, rather than try and do this to do or uncover every type of vulnerability class, we focus on cross-site scripting. And we did borrow the approach from the Takayasu, the Japanese researcher I mentioned towards the start, because he'd published a lot about this. And he'd had some successes using long short-term memory recurrent neural networks. With this, though, we did have some challenges. The researcher who was working on this piece wasn't sure about how or when to tweak the mutation rate, the training rate within the algorithm, and the different evaluation functions that you use throughout the process. And also, as you start going into recurrent neural networks and you're learning to do stuff, the compute power is pretty insane. You need a lot of power and GPU at a minimum. So he ended up using a Dockerized Selenium multi-threaded hub solution to sort of do a lot of simultaneous multi-threaded stuff, because initially he was having a runtime of 10 hours just to learn to do a very simple cross-site scripting. He managed to get that down to 10 minutes, which is a bit more usable, but still, isn't ideal in terms of if you have a high turnaround or a need to do a lot of testing quickly. This is just sort of one of the example outputs from the algorithm trying to learn to do cross-site scripting on a particular input field. Apologies, it's a bit small, but it's just showing the different scoring of the evaluation function each time it's iterating different things. And I'll zoom in down here. This one was quite funny, because one day Thomas, my colleague who was doing this, sent me this email saying, I've just been trolled by my own creation, because he was sending lots of LOLs back to the screen as I was trying to learn how to do cross-site scripting. There's still a lot more work to do there. Like I said, Takayasu has had some gains there, but we're convinced that we can get better improvement here. The issue that we had here, and the lesson learned was, and Thomas is open about this, is that he wrote everything from scratch in terms of doing this. And that comes with a big overhead. It comes with a lot of questions in terms of how you're validating your approach and what you did. Given that Takayasu had published a lot of results that looked promising and had published some code, our next step is to actually use what he's done or see if we can get some better performance from what someone else has done already. And then lastly, we tried expert-based systems. So expert systems, I guess they're a type of artificial intelligence, but they're quite old. They're a specific, subclass of AI. Basically, it's a program that emulates decision-making and how we as humans think and follow actions to come to an inference or a decision. It's very proven in medical diagnosis and other fields that have a strict requirement to follow a rigid methodology to understand why an outcome was the outcome that it was. At its heart, it's simply a series of if-then-else rules. It's a way of codifying, I guess, how we as humans would go through the process of trying to uncover a specific class of vulnerability and what the different facts we would need along that way and the inferences that we would make. For this, again, we developed a plugin for Burp Suite based off this open source Java-based expert system called Clips. It's very old. This came out of NASA. It's from the 1980s. So it is still very applicable. And the fact that it's Java-based made it quite accessible to Burp Suite as an extension. So what we were going to do here was try and automate, again, focusing on cross-site scripting, some of the monotony of trying to find or at least confirm cross-site scripting. So for cross-site scripting, you identify potential parameter in a page, whether it's reflected back, that sort of thing. You confirm that the value is controllable. Those first two things, Burp does that for you already. You're already sort of pretty much mostly there. It's this last step where we wanted to hook in the expert-based system to test the value or to go through the process of determining, okay, this value that's reflected back or stored is actually vulnerable to cross-site scripting. So again, we were using Damn Vulnerable Web App here just for a very simple proof of concept. For this example, this is one of their stored cross-site scripting. And here we have a few just facts that we assert. So we have a controllable value that's stored in the back end and is returned in a response. So it's like a message board type thing. The stored value occurs in plain text, so it's not inside an HTML tag or JavaScript. And the length of the input is 7 characters. So the way that the expert system works is you assert those as facts into the Clips environment, following a few different rules that you've set out. So just to sort of in a bit more detail there. So this is the syntax for Clips. Is quite sort of, I guess, of the 80s for a start, but it's quite hard to sort of learn this. And I know Richard, our researcher who worked on this bit, did battle with this for quite a while, but managed to get it working for a very simple example. And here we're testing the length. We're testing that it's less than 30 because the final attack string or payload that we send is 30. So that's something that has to hold true for what we're trying to test. And then goes on and sort of checks after the length aspects about the angle brackets. It asserts sort of the less than, great than type properties, whether it's in text, whether it's stored, that sort of thing. But these are all sort of rules and assertions that we as the researchers have to type out and codify as part of the expert system. But in a very simple example, Richard did manage to show that, yes, you can automate to a point this methodology or process. Observations there, though, I think I've already touched on them, but there is a very steep learning curve to CLIPS particularly. I mean, there may be other expert-based systems out there that have an easier syntax to learn with, but we just used this one and did find it sort of slowed us down a bit. Converting the human knowledge into those rules is, of course, very laborious. But the payoff is very positive, because once you've got it and it's working and rigid, you've codified that repeatable methodology that the expert system can follow. But if you think about, if you wanted to cover all classes of web app, all different types of cross-site scripting, that massively explodes the number of rules that would be needed to be codified for something effective in this space. And then a few people, when we were doing this research, asked, well, how is this better than Burp's Active Scanner? Burp's Active Scanner is pretty good. You just point it at a few fields or input parameters, and it tries a lot of different stuff. The difference is that this has the potential to be a lot more efficient, because rather than sending loads and loads of different attack payloads in a noisy manner, this is going through methodically. And also, when this fails, this tells you why and when it failed. So it gives you the reason why cross-site scripting can't or won't work in this example, which the Burp's Active Scanner won't do. You don't get that feedback. So it's quite a nice approach in that sense. So despite being hard, we do feel that there is mileage with expert systems in web app testing. But again, the running theme, we need to do a lot more testing in this space. So some conclusions we've got from this, just to sort of wrap up and what the main points were. We did find that concentrating on specific classes of vulnerability is much easier. If you're interested in sort of setting out to do similar stuff in this domain, if you try and do a one-shop type catch all classes of web vulnerability, it's going to be very hard. So I think the best approach is to focus on, can I use machine learning or AI to detect and exploit cross-site scripting, SQL injection, that sort of thing. The need for real-world data is, of course, very paramount. It sounds obvious, but we learned that quite quickly, and that could often be quite the challenge. It's a lot of data gets generated all the time, but there are various restrictions around how easily we can access that data. The anomaly detection method did show some good potential, especially with the feature engineering and the issues that gets around data protection. So we're definitely going to be exploring that more. And the reinforcement learning, that's very exciting, but it's hard. It's exciting to sort of have something actually learn how to do something and then get really good at it. But it's hard because there's a very steep learning curve. There's a lot of data science involved. You need a lot of data. You need a lot of compute power to get some good results there. And then I haven't really mentioned it, but thinking ahead longer term, if or when we get better results and capability here, is the issues around retraining or understanding when is it a good time or when should we be retraining models. A big concern that I've got with any application that uses machine learning or AI is what I think Royal Holloway in a paper wrote about called concept drift. So if you think back around sort of intrusion detection systems when they came out many years ago, everybody was buying them in, rolling them out, adding signatures, and then they had their IDS, and it was doing stuff, alerting, blah, blah, blah. But I don't know how many of you have worked sort of network security over the years or worked with people who use IDS. But we commonly would see or work with clients who had an IDS system, and you talk to them about, well, when did you last update your signatures? And they say, well, maybe 3-4 years ago or something. And so they have a system that's looking for is trying to detect intrusion that probably doesn't exist anymore. The attack landscape has moved on, the techniques have moved on, and so those systems are effectively redundant. They're not doing anything. And I think we're at the cusp of experiencing something very similar with machine learning and AI, in that if you're training your models on what we are seeing now in terms of attack techniques, procedures, that sort of thing, if you're not retraining that to keep up to date with the change in threat and attack landscape, then I think the same thing will happen as we've seen with IDS in the past, that the models will become less and less effective. And so this idea of concept drift, that the concept of your initial model is drifting away and becoming less useful, is very important. And so we are wanting to sort of get on top of that earlier than later, so that we don't end up repeating that same mistake with machine learning and AI. The expert systems, they showed good promise, but like I said, there's a steep learning curve in learning the sort of syntax of some of the frameworks, but it does show a good, potential, robust method of doing testing with that feedback loop. And it is, of course, technology agnostic in sort of the way that it goes about trying to uncover flaws. I didn't mention intelligent crawling in terms of what we were doing because we weren't looking at that, but a lot of people are focusing ML and AI on the intelligent crawling aspect of web apps, because if you can intelligently identify what different functions are within a web app and infer, that's a search field, that's a login field, that's a good step towards getting better automation. You could then think about hooking in your well-trained models that detect cross-site scripting or SQL injection after you've done that intelligent crawler to get to a point where you have a fairly decent automated web app testing capability. But we didn't focus on that, but it is a relevant piece or part of this type of research. I guess obviously, but machines do lack contextual awareness, so regardless of how successful we or other people might ever be in this domain, we'll never get to a point where the machines, this gets a bit philosophical, but the machines don't know what it means to search or to log in. Even for us humans, we might see a simple GET request and see a parameter called S. We might know just from having seen the app and what that request is that the S actually means search or search string. Those sorts of things a machine won't easily know or understand contextually. And so I think, even though we can envisage a time where maybe we do have a level of machine learned automation and web app testing, I do think that there's always going to be a role for that human-based inspection to get that better inference. And then lastly, accuracy. I mentioned it as a running theme throughout the talk, but there is a big danger to sort of create a model, do some tests, the frameworks come back and give you a 90% plus accuracy, and for you to think, well, hey, I've cracked it, here's my solution. But for all the reasons I've discussed, things like you need lots of data, the issues of concept drift, we are exercising a lot of caution there before we make any claims about actually how good our models are. So in terms of next steps also, we do have another research, round to build on our lessons learned from Project Ava, and we'll look to home in on more detail on some of the approaches that showed most promise. We have an internal conference every year called NCCCon. We were hoping maybe in 2020, it's in January, so it's probably a bit too soon, but maybe by 2021, within that conference, we're going to run a People versus Ava competition where we'll have a never before seen web app to either our consultants or Ava. She will have been trained on her various techniques, and we'll give them a time limit to find as many flaws as they can. We'll see who the winner is. That's just a bit of a fun thing to do, but it'll be interesting to see what comes of that. That's sort of certainly helping us focus our aims to get to that competition type setup. And then just to summarize, in terms of a couple of quotes, my personal opinion from this research journey and what we'd observed was that, I do think that machine learning techniques will definitely form part of a web app tester's toolkit within the next 2 years easily. Not necessarily just from us. We may or may not be able to release something, but I'm sure others will. This stuff in the wings about to drop. There will be techniques that we will be using. However, Vivienne Ming, a very well-respected AI researcher, individual, I really like her quote about how AI might be a powerful technology, But things won't get better simply by adding AI. We certainly did learn that. There is a lot of hype about AI and machine learning. It's not necessarily best fit for a lot of things that we were trying to do, or sometimes it will give some efficiency gains, but it's not going to solve or automate us out of a job anytime soon. That was me. Thank you very much. Diolch yn fawr. I will take any questions. We didn't. That's a good question. Yeah, sorry. So the question was that seems that it might be easier to do a lot of this with white box assessment if you have the source code, so using various techniques over the source, rather than this, a very black box approach. Great question. Yes, I agree. If you have source, you can obviously do a lot more. I think I don't know what others in this room think about if you work in pen testing, but for whatever reason, within the UK, what we've noticed with NCC is still compared to our US colleagues and how they work there, there's a bigger reluctance to hand over source code in the UK. A lot of the pen test engagements are much shorter, always black box. There's still quite an attitude of, well, the bad guys wouldn't get the source code, so why should I give it to you, sort of thing. We often have to contend with that. So I think that's mainly why we went down that avenue, because it's most of the work within the UK sector that we do. It's often quite black box. But no, I completely agree that exploring techniques across source code is equally a valid research domain. Yeah. Sorry, you say that again. What is machine learning is knowing why, on what basis it comes to that sort of conclusion? Is that concern? What aspect of the data is it going? That's why. Yeah. So the question being, so a big issue with machine learning is not necessarily giving you that feedback as to why it made a decision it did. It's that whole black box aspect. Yes, it is a concern. Definitely. We would not want to release this or use this on in terms of gaining client assurance if we didn't have trust in it. Yeah. Any other questions? No? Okay. Thank you very much.